right? Big deal, it's just a variable. Also, this is not an equation, right? It's not an equation. Do you see any equal signs here? No, right? So this is not, we're not talking about this at all, right? This is just what we call an expression, and what we want to do is simplify that expression. So when I look at this, I say, okay, well, I see some like terms in here. I see a 3a, I see a, 2a squared, 2a squared. These are like terms, these are like terms. The problem is this parentheses, right? So I need to get rid of this parentheses before I can combine anything together. And I need to get rid of this parenthesis. So what do y'all think? Let me ask, let's see here. Jareth, you're up. So what would happen here? How do you get rid of this parenthesis here? You have, don't you, to remove a parenthesis, don't you have to distribute the number in front? Yeah. Okay, so what number's up here? 1. 1. So if I multiplied a 1 through here, it wouldn't do anything, would it? But the parentheses would be gone. Yes, so basically, I can just drop this parenthesis. You're our Jareth, right? Yes. Want to make sure I get that? Okay. I wouldn't want to call you Jareth if you're not. Okay, so that I just drop, right? The second parenthesis, however, Jareth, right? This is a -1 in front. And so when you distribute that through, it has the effect of doing what to all of those?
Just multiply -1
Mm-hmm.
with all of them, so negative a,
Yeah.
negative 2a squared, and then 3a cubed.
Yeah, so it just changes all the signs, right? Everything that was positive becomes negative, everything that was negative becomes positive. So now we have the -a minus 2a squared plus 3a cubed. And now at this point we can start putting things together, all right? So let's start putting things together. Sarah, now we'll call on Sarah now. You ready, Sarah?
Yeah.
You sound very enthusiastic about that. Okay, so Sarah, let's do like terms, okay? So I'm just going to look at this one right here. What is a like term to this one? The -a, right? Okay, when you put those two together, all you have to do is put their coefficients together. So you take the 3, and this is a -1, right? So what would you get? 2a, right? Everyone got that? By the way, I should put equals here. We're saying this equals this, which equals this. Good, Sarah. What about the next one, Sarah? That one is like term to this one, right? Because they both have a squared. So what do you get there when you put those two together? So do the numbers, right? Do the numbers. You take 2, positive 2, and you subtract 2, which would give you nothing, so that it's gone. And you don't have any letters left over. So it's actually like you have 2 apples, you take away 2 apples, you have no apples. So there's nothing here. I don't need to put 0 here, but I'm going to just to make sure you understand, everyone understands what happened there. And then what about the last one? Ashley? 6a cubed, right? 6a cubed. So 6a cubed, that's this together with this, right there. Okay? So your final answer would just be 2a plus 6a cubed. Box it up. That is the simplified version of that expression. Questions? All right, you're not going to like me for this one, but this is a good example of what I like to put on a test. All right, so anytime I say that, you want to put like a little star next to it, and remember when you're studying for your test to go back and look at it. Okay, how about this? -2 times 1/3 x plus 4x squared minus 2/5 minus 4/3 x minus x squared plus 1/3. Same instructions. Simplify. So notice this is not an equation, right? Same, like we're not doing this over here anymore, right? We're just going to put these things together. So when I go to put these things together, I can already start to see that I have like terms. I have an x here, x squared there, x squared. So I have some like terms. I also have some numbers, 2/5, 1/3. So I'm going to be combining things together, right? But I first need to free everything from the parentheses. So I'm going to have to distribute this through here, here, and here. I'm also going to have to distribute this minus, like a -1, through here, here, and here. All right. Alicia? You're up. Okay, you want to go with that first piece?
Yeah, so when you multiply -2 times 1/3 x, you get -2/3 x.
Negative 2/3 x. So let's make sure everyone understands that. Very good. You're multiplying these two together, right? And so you just look at that -2 is a -2/1, and just multiply those two fractions straight across. -2/3, right? -2 on top over 3, and then keep the x. Good. -2/3 x. You want to keep going?
Yeah, so then when you do -2 times 4x squared, you get -8x squared.
Good.
And then when you do -2 times -2/5, you get a +4/5.
Positive 4/5. Very good. Okay. Yes. Okay. Very good. Very good. Now, you did so well on that, I think you'll be okay with this also, because it's just a negative through, right?
Yeah,
So,
I haven't gotten there yet, though.
okay. No, but I think you can just talk through it. I'm confident that you can. So here to here would give you, this is positive, right, Alicia?
Yeah.
And you're going to multiply it by -1. So all it does is changes that to a minus, right? Instead of a positive 4/3 x, it becomes
Oh, yeah, that's right there.
minus 4/3 x. And then that keeps happening. Everything changes signs. So what do you get?
So then a positive x squared,
Yep.
and then a -1/3.
There you go. Whew, okay. So the reason why this one sucks is because at this step, when you combine the like terms together now, right? When you do, like, here's the x. Let me color code these. These are like terms, right? These are like terms, and these are like terms, right? So you got to add the reds together, the greens, and then the purples. So when we do the red ones, right? When we do the red ones, have I called on everyone? I feel like I have. Did I miss anybody? I'll take a volunteer then. Someone want to tell me how they would do the red ones? Okay, how though? You're going to do what? Just tell me what you're combining together. Taking -2/3 and subtracting 4/3, right? 4/3. Remember, we said when you add or subtract like terms, you look at the coefficients, right? You take that number and this number, and you have to put those together through addition or subtraction. So really, this is like on the side, I'm doing scratch work. I'm taking -2/3 and I'm subtracting from it 4/3, right? That's what we're doing. Now, when we go to do this, we have to remember how to add and subtract fractions, right? Now, fortunately for us, these have the same denominator, don't they? And when they have the same denominator, all I have to do is do the -2, take away the 4, keep the denominator. This gives you -6/3, which reduces to become -2. right? So that's all I have for the x. So this is equal to, I have a negative 2x. And now I have to do the same thing for the green ones. Well, the green one's actually, I think, going to be better, isn't it? Right? Because it's just negative 8. And you take the number in front here, 1. Negative 8 plus 1 is negative 7. Right? So negative 7x squared. And then the last thing is the part that I think is the worst part of this, is you've got to do 4/5 take away 1/3, which unfortunately requires us to do, I'll do it right here. I got to do 4/5 take away 1/3, and here I have to get a common denominator. So this is like on your test, right? Your exam, your first exam. So you should have methods for doing this. There's kind of two ways to do it. I showed you both ways. Students did it different on the test. Some people like one way over the other. I'm going to do the short way where you go like this and go 12, and this times this and go -5, and then multiply across the top or bottom and get 15. So I can't do math. 7 over 15? 7/15 is the number you get. So your final part here is plus 7 over 15. There it is. See, I like problems like that because it requires that you demonstrate a lot of things to me, right? You know how to distribute. You know how to multiply a number times a fraction, right? You know how to combine like terms, which requires you to add and subtract fractions, and then yeah, so there's a lot there. Any questions on that? Okay, shifting gears. Still working with this, but doing something different. All right. I want us to multiply this. Another way I could ask you to do this is to say expand this. Okay? So here it is. I want you to take 3x minus 2 and square it. So when we have to go back and remember what it means to square something, right? If you write 3 squared, you mean 3 times 3, right? That's what the squared means. You're going to take whatever's down here, multiply it times itself. So when we square this, the first thing we need to do is take it, write it down in parentheses, and then take it again, write it down in parentheses, and multiply those together. That's what we need to do, right? It's like 3 squared is 3 times 3. Well, 3x minus 2 squared is 3x minus 2 times itself. And how do we do that? I'm sure y'all have learned how to do that. Yes, sir? Okay, so when you learned it, that's the way I teach it. I like what you just said. Did you learn FOIL? Did anyone learn FOIL thing? Show of hands. FOIL? Yes? So FOIL is taught a lot. FOIL is a way to remember how to do this, and it stands for first, outer, inner, last. I'm not a fan of this. You can use it if you want, if you're happy with it, be happy with it, okay? I'm not a fan of this because it only works if you have what's called a binomial. What is a binomial? 2 terms. Bi meaning 2. 2 terms, binomial. 2 terms times 2 terms, you can use FOIL. But if you have 3 terms times 2 terms, or 3 terms times 3 terms, you can no longer use FOIL. So as great as it is, it's limited. What's better is to have a procedure. And the procedure is this. All you do is start with the first term here, distribute it through with multiplication. After you've done the first term, then you will move to the second term and distribute again. I'm going to put the little things down here so you can see them, right? Right? And once you finish that, you're done, okay? Start with the first one, pass it through. Second one, pass it through, finished. If you do it though, if you think about it, when I do this, here to here, that is the F in the foil. And when I do here to here, that is the O in the foil, outer. And if I do here to here, that's the I in the foil. And if I do here to here, that's the L, the last in the foil. So it's the same thing, it's just no cute little name for it, okay? So let's do this. Volunteer, someone new. Not that I want to hear you, sir, but just to keep it going. Volunteer for the first term on this one. What is it? 9x. So we're multiplying these, right? So the 3 and the 3 become a 9, and then the x times the x? X squared. Good. So 9x squared. And then, let's see, what about the next one? Here to here. Minus 6x. Here to here. Minus 6x. Almost done. Plus 4. Okay. Now, once we get here, only thing you need to concern yourself with is possibly combining like terms, if you have them, which in this case we do, right? These two are like terms. So this becomes 9x squared minus 12x plus 4. Okay, good. Now, what's the big mistake? What's the thing that we see students do wrong on this? I hate to show the wrong way to do something, but it's worth it because it happens so often. Students will simply square each one of these. So they'll say, oh, 3x squared, that gives me 9x squared. And then they'll say minus, and then they'll say, oh, 2 squared is 4. And this is completely wrong, all right? So don't do that. Anytime you square a binomial, you must expand it out like this. You can see if you compare this answer to this answer, they're almost the same, right? Well, you got a 9x squared, you got a 9x squared. You got a 4 here, minus 4 is plus 4, And then, of course, this has the minus 12 in there, so.
Wouldn't it have been plus 4 because the timesing it by itself?
It depends on how you do it. That's what I'm saying. Like, it would depend on how you do this. Like, some people might do, like, 2 squared is 4, and I'll just keep the minus. Then other people might say, oh, square the negative 2 and make it positive 4. Either way, it's wrong. You know what I'm saying? Like, either way. So just don't do this. Okay, questions? All right, let's try something else where you can't use the FOIL. So how about if I gave you this? R plus 2, R cubed minus 3R squared plus 7. And I ask you to multiply or expand that. Do you see what I'm saying that you can't use FOIL anymore? Binomial, 2 terms. What do we call this with 3 terms? Trinomial, right? What about 4 terms? Quadnomial, right? Yeah, we start not having names for them anymore. Okay, we do bi, tri, that's about as far as we go. Anything, they all live in a category, in a thing. Look, if you take, these are all the binomials. Think of this as like fish, okay? Binomial is a type of fish, all right? And then you have trinomials. I'm just going to put tri and trinomials. And then maybe like quad, which would be where they have like 4, right? Quad. Well, all of these belong to a big group of things called polynomials. Polynomials. All of these are called polynomials together. So it's like this might be I don't know, a shark, a dolphin's not a fish, is it? It's a mammal, right? A shark, some sort of tuna. What did you say? Tuna, yeah, tuna, that's what I thought of too. So these may be certain types of fish, but they are all fish, right? So polynomials is a big category of these sorts of things, right? That's a polynomial, specifically a binomial, specifically a trinomial. Understand? So I'm multiplying a bi times a tri. And I'm going to use this method where, how am I doing on time? I'm going to use this method where no FOIL. I want to ask somebody. So who's my new volunteer? Go ahead. How would you, using what I just kind of showed you, what would you do?
I would push the R through.
Push it through? All three, right?
Yeah, and then I would push the 2 through.
Then push the 2 through, and that's it, right? You'll be done after that. So how many multiplications are you going to have to do here?
A lot.
How many?
That's 6.
6, right? You had 2 and 3, binomial, trinomial. You had to do 6 multiplications. If you had a try and a try, how many do you think you'd have to do?
12.
If you had 3 and 3, 9. You would have to do 9 multiplications. It's always however many are here times however many are here. So if this is 2 terms and this is 3 terms, you're going to need 6 multiplications. That make sense?
Yeah.
Okay. So go ahead. You want to keep going? Tell me what it is.
So for the first part, R, whatever, R to the 4th.
R to the 4th.
The negative 3R to the 3rd power. Or
Good.
cube,
Yep.
and then 7R.
Good. All right. Next volunteer to continue. Good work. Who's going to continue?
2 more.
Oh, yeah. You can always use the rest. You don't need to ask.
2R cubed.
2r cubed. So plus or minus or what? Plus 2r cubed. So that's, you're doing this one to this one, right? Okay. Keep going.
Negative 6R squared.
Okay.
And then plus 14.
Plus 14. There we go. Questions? You look like you have a question. I didn't even look to see if this was right. I was hoping it would be, something would be wrong and someone would point something out.
Would it be negative 1R?
So when we go here to here, which one are you talking about?
The second distribution.
So the 2 through here?
With the 3.
So it'd be minus 6, right? Because you're doing 2 times negative 3. Oh, you're multiplying. I think you were subtracting them. Remember, what we're doing here, when we take this and we pass it through, what we really mean is 2 times negative 3r squared, right? That's what's happening. And this right here is multiplication. So you're multiplying those 2 numbers together. That gives you negative 6. You know, the only way you're going to add or subtract the numbers is if we're doing addition and addition and subtraction between like terms, which would happen at this step. See, here's where we have to combine this and this together. Let me see. Like terms here. The like terms we have here, these two. Do you see what I'm saying? Like at this step, when we're combining like terms, that's when you're going to add and subtract these numbers together. But when you're doing the distribution or the expanding, you're multiplying the numbers, not adding or subtracting. Okay, here we have like terms. Those are the only 2 like terms we have, are they?
Yeah.
Right? That's it. Okay. So we still have r to the 4th. Those 2 together minus r cubed. And then plus 7r minus 6r squared plus 14. Any questions on that?
Would you have to put it in order?
I was hoping you were going to ask that. I was just about to ask everyone right now. I was going to say, is that correct to leave it like that? Well, look at the powers. 4, 3, right? I'm looking at the powers on the R. 4, 3. The power in this one is a 1. The power in this one is 2, and then 14. The powers don't go down, do they? They don't go down. I mean, they go down, then they go back up, right? This is still correct. It's not wrong to do this. Now, what we do like to do, we do like to put it highest power down. We like that, but it's not wrong if you don't. So if you do that and do powers down, it's called descending order. Putting it in descending order. Okay, we good? Questions? Comments? Okay. So I have a problem now that's going to seem like it's coming out of nowhere, all right? It's a geometry problem. All right? So I'm going to draw a rectangle. I'm getting ready to build this shed in my backyard or something, right? There it is. Kind of starting to sketch out what I'm going to build. I'm not quite sure how big it's going to be, but here's what I can tell you. This side is going to be, this side right here, let's do this one. This side is going to be some value x. I'm not sure what it is exactly yet, okay? And whatever this side is, I want it to be 3 times bigger than that. 3 of those. So if this is 10 feet, I want this to be 30 feet, right? Now, when I build this shed, I'm going to have to make a cutout for a covered porch. Okay, so what I'm going to do is over here, like this is going to be the ground, but I'm going to have to cut out over here the corner where I'm going to have like a door to come into this thing. I'm just making this shit up right now. Okay, and what I want this to be is I want this to be 1/5 of x here, and here I want this to be, let's go 2/5 of x here. So however big this is, I want that to be 1/5 of it and that to be 2/5 of it. Y'all with me? Here's my question. I have to figure out what my walls are going to be. I want to know this distance around. Okay? That red. That's called the perimeter. Find the perimeter. Not of the whole thing, just of the red part, right? So let's see if we can figure out what this will be. So perimeter will be, y'all help me out here. If I start from here, start walking around, I go from here to here, I'm going to need what distance? From here to here? 3x. So my perimeter will be 3x. Okay, that gets me from here to here. Now I go from here to here, which is x. So I'm going to add to that x, right? With me? Now, from here to here. That's the tricky one. It's one of the tricky ones.
3/5 x.
3/5?
Because it's not the 2, that means the other 3 part would be that distance.
Yeah, I think you're on the right track.
Wouldn't it be 3x minus 2/5 x?
Yeah, so look, the distance from here all the way, right, wouldn't that be 3x? Because that's this, right? But then we want to take this part away. This piece is, what? From here to here is what? 2/5 x, right? So that's 2/5 x. So that means this red part must be that whole part, take that away. Understand?
Yeah.
Everyone see that? The whole 3/5 x, take away the 2/5 x. Hello? So I'm going to say here, plus the 3x, take away the 2/5 x. I'm going to put this in parentheses just to kind of stress that this right here is this side, right there, from here to here. Understand? So now we're here, right? Keep going around. Here? 1/5 x. Here? 2/5 x. So I'm going to put that plus 1/5 x plus 2/5 x. I'm going to run out of room. At least I'm going to go off the camera, but I'll continue it on the next line. So now we go on 1/5 x and now 2/5 x, and then the last piece we got to go from here to here.
X minus 2/5 x.
Close. X is this, right? And you want to take this much away. And that's 1/5, right? So this should be the whole thing x, and then this piece is 1/5 x. So you do the x, take away that much. I'm going to have to continue that on the next line. Plus x, take away 1/5 x. And do you see you have something now that you could add all this together and get combine like terms? Right? And get one final answer at the end? Keep in mind also, I do not need these parentheses, right? So if you had to put this together, you could just drop these. The only reason I put them there again was to kind of stress where it came from. It was that one side right here. Okay, so you can just drop those and combine. I'm not going to finish this problem. Equals whatever. You can finish this now. I wanted to show you how you could take some sort of geometrical problem and turn it into something that we've been doing today, which is combining like terms together. Okay. We only have 9 minutes. Whew. So for your homework in this section, let me just go back. I think last time I had you do page 226. Did I have you do anything on 226? I need to look at the notes. Let me see. Well, I'll just tell you. So page 226, 227. So for your homework, for what we've covered so far today, page 226, 227 in the packet. I would say do as much as you need to feel comfortable. All right, so if you feel good about it, just make sure you do a couple that maybe look a little weird to you. That way you're prepared for any test problems from that section. Yeah, now I'm wondering what to do here. I only have 7 minutes. Let's do this. I'm going to start getting us ready for the next topic that we're going to talk about next time. But I thought I would get us at least our brains going a little bit today about this. All right. Next time, what we're going to be doing, this is homework, is we're going to be talking about lines. And specifically, we're going to be wanting to be able to graph lines. All right? So let's just talk about lines for a second. When you take like a flat sheet of paper, we always like to put these two axes on here. We call this usually the x-axis and the y-axis. I know you've all seen this before, yes? What do you need in order to define a line? You only need 2 things to define a line, right? What 2 things? 2 points, right? Give me 2 different points and there's only 1 line between the 2. Agreed? Give me 2 distinct points. So if you give me a point, you give me any other point, there's only 1 line I can draw between those, right? 1 line only. Also, if I draw a line, it's usually going to hit this x-axis somewhere. We call that the x-intercept. I'm going to put x-int. And then it usually hits the y-axis somewhere, and that's called the y-intercept, y-int. Is it possible to not hit those? Is it possible to draw a line that would not hit those? How?
In the same project?
How do you mean?